Okay, so I think things should be working fine now. There was a minor glitch, so changing on the link, and we have things up now, right? There was this weird issue that it was not reading the monitor that I use, so I had to restart it. I don't know how to like kind of pause it up. There's some issue over there, but no problem. We will kind of continue with that itself. Yep. So that's the link that we had for the quiz. You guys can check out the quiz over there as well. Just want to check once if I hope people are not waiting on the other video, because that would be pretty. So if the chat of the other one is there, like maybe you can write in over there that this is the new link where we will be following things up. Great. Chalo, let's continue discussing the things that we have for today. How do we start with riddles, right? So for the problem of riddles, we yeah, like Sandeep, you can post up a quick message over there that this is the new link, and you can join up there. I think there was this minor issue. Okay, so we will start with the first problem over here in the MCQs, and that will be the place where we'll start with. Okay, just I'm just waiting for 1 minute so that people can join in, so that we can start with this one, right? So let's chat. After that, we'll move to the problems. How many people do we have over here? Everybody ready? Chalo, let's start discussing. Okay, so let's start with this particular question, and we will start discussing the chat questions as well. Like the Sadhvik has asked a very good question. I will talk about that. Yeah, I will talk about the basics ideas, and then again I will give you guys some time to kind of go through the editorial and solve them. So this is the famous matrix multiplication problem. There is this classical problem called matrix chain multiplication problem, which is given four matrices, you have to multiply them in a way that you get the lowest cost, right? And this is an actual application of LRDP, right? So what kind of form over here we are using LRDP, because in this case wherever you have to break things inside subarray, like you have to decide which one. So wherever there is a sequence where you have to put brackets, right, it's a problem of LRDP. Be that expressions, be that multiplications, be that matrix multiplications, be that anything, right? Wherever you have to decide the brackets or how the operations in which order they happen, it's a problem of LRDP, because the each of the independent things can be a subarray. Okay, so it's a LRDP problem. So matrix chain multiplication is an LRDP problem. Okay, given two strings SRT, find the number of distinct subsequences of S which are same as T. Okay, find the number of distinct subsequences of S which are same as T. So how many subsequences, like how many places does T appear as a subsequence? That's what we are interested in. Okay, so we are given two strings, right? We are given two strings, so it's a matching DP, right? That for the first string we will keep moving forward, and the other one how much we have matched till now. So it's a, whenever you're given two strings, most probably you need to do it in some way of LRDP, or sorry, the form 3, which is matching DP, right? What could we be the states for solving the partition equal subset problem? Find if the given array can be partitioned into two subsets such that sum is equal to E. How can we do this? So it's actually C, right? Both A and B, because this is nothing but the problem where you have to divide the whole set into two subsets of equal sum. Okay, two subsets of equal sum. The way what works is that, like, if the total sum is X, then you have to decide a subset of size X by 2. The other will be equal to X by 2 as well, and it's equivalent to the knapsack problem, or the problem that we have solved in the class, that you have to find the subset of sum X. So in that case you kept correct index at the correct sum. Later on we discussed that maybe to optimize it, how much sum is left would be better choice, but for this one, both of these if you keep, it's good enough, right? Given a 2D matrix for n and m, Find out the maximum sum of a path from the first to the bottom right position of the matrix. You can move in three directions. Downwards, diagonal downwards, left, diagonally downwards, right. Okay, got it. How many average number of transitions? Turns out three, right? Like it says that you have three directions. So whatever the number of directions are there, that is will be there, right? Okay. Given an integer n, find the number of n-digit numbers whose sum of digit is prime. That's a really good question. How do we solve this one? Sum of digit is a prime. Okay. So we have to find out the number of n-digit numbers whose sum of digit is prime. So if I go over here, we have to kind of fill this n places, okay, with some number 3, 2, 5, 7, so on, such that the sum of digits is prime. Okay. So what we do we need to keep a dp of index, the digit that we are filling in, and what is the sum of the things that you have got till now, sum, because what is there that we need to check at the end. At the end, when you have a particular sum, right, when you reach index equal to n, okay, when you reach index equal to n, if prime of sum is equal to 1, okay, in that case we can say that this is a valid number, or else it's not a valid number, right? So it's not a digit dp per se, it's just to find out the sum. We have to maintain a sum of the numbers, and at the end we have to check if it's prime or not. Okay, so in general it's definitely a dp problem. Digit dp is when you are given that you have to find number in the range L to R. When this number, if the question would have said that find the number of numbers in the range L to R such that the sum of digits is a prime, then it would have been a digit dp problem. But we are not dealing with digit dp today. Over here it's index, sum, and you have to at the end check the thing over here. Okay, for each place we have almost 10 transitions except the first place, which is 0 is not possible. That is correct, that's true, that's the correct transition. There is a very important concept over here, right? In one of the videos I said that we keep states to model restrictions, but in this question there is no restriction maybe, right? We sometimes also keep this sub so that we can check the condition or being valid at the end, so that is like a check over here. Or sometimes we can also keep some state over here that will help us compute the value of the final state, like of the base case. Sometimes we just want it to check, or sometimes we just want it to be there so that at the base case we can do some other check and then process it accordingly, right? So this is also possible as one of the possibilities. So this is there. To check for prime, maybe we need to keep track of which number is a prime. So we can do it naively too, but in general, if I go back to the setup, maybe both A and C might work. Which one do you? So this is like a bit dicey. Like MCQs come up in some test, right? And you might have some doubt about something. Which one do you think? Should we put up with D with A? See if can help us with finding the numbers in the range 1 to some prime, some number. So should we use sieve or D? D sounds good. Like at first it looks DP, but maybe to find out prime we might need sieve. So sieve also comes into action over here. Though this is also some problem which requires some constraints and all, but still I just wanted to give you guys an idea that okay, sieve can also be done as a pre-processing that can help us later check this prime quickly. And this is a subjective problem, right? You are given n items, the weights of this are given, and the maximum value you can carry at the value vi, you can carry the w weight. You need to maximize the items value that you carry, right? So this is the question. But again, in this particular part, the weight given is very large, and but the values are small, right? Here weight is very large, but the value is very small comparatively, right? So how can we do this one then? Okay, so this is actually, that's correct, sure. This is nothing but AtCoder's knapsack 2 problem or E problem, right? Yeah. So there is this concept of optimization which comes into place. So what we were earlier returning was dp of level, comma, the weight taken, maximum, maximum value you can make further, right? How much weight you have taken. But it turns out that in this problem, if you weight taken over here, it can be up till less than equal to W, and W is still 10 to the power 9. And every weight could be possible. So if you calculate the time complexity, order S would be nothing but over here there are n items multiplied by 10 to the power 9, which will never pass. Some people are saying that maybe use a hash map as DP. It will not work because every possible of weight is feasible, right? Let's say there is just 20 items, or let's say there are 30 items. Okay, 30 items with weight 1, 2, 4, 8, so on up till some like powers of 2s, right? 2 to the power 30. Let's say with this I can create any particular weight that you want. So every state might get hit. Okay, so using a hash map doesn't really save us from the type complexity. Okay, so this is not feasible to be solved in the regular way. This is one exception to the rule that we learned, that we always return what is asked. In such problems where you have something very small that vi is given to be up to 10 to the power 3, we sometimes rotate the state. So this is called state rotation. dp of level. So in this case we need to be a bit constructive. This is exceptional problem though. This is like exception in the whole thing, whole rule that we have learned. That maybe what we can try and do is we can keep what is the value we have got till now, right? So remember the way it was, like we were having some weight at v, and then you are dealing with this level right now. Okay, so till this much, how much value have you accumulated yet? And what you're going to return is, or how much value you want to get, maybe that is also feasible. How much value do you want to get? How much value left to create? Okay, and what we're going to return in this case is minimum weight needed for it. Okay, so the question was that you are given W weight, find out the maximum value that you can create. But in this case we rotate the states and say that for a given weight, for a given value that we have to create, how much minimum weight is required, how much minimum weight that we will have to pick up, right? So this is another idea called state rotation. I'm not going to discuss this problem today in the stream. This is going to be something that we take up in the solving stream when we solve AdCoder problems directly. But I will explain you this particular problem in depth. This is nothing but AdCoder DP contest E. If you want to try it up before that session, feel free to do it. We don't even need binary search for this one. This is not binary searchable actually. It's looping over all values, but it's something we'll take up in the separate stream. Okay. Yeah, exactly. That's the idea. Okay, so this is what we create as a new state. So sometimes it might not be as same as this one. So I just wanted to kind of keep one like quick note over here that you might always not have the same thing that is asked in the problem. So this is an exception to that rule. But again, most of the problems that we have seen till now works with the rule that we have, right? So even in chemistry that we used to read, we used to had a lot of rules that made our life simpler for a lot of things. But always there was some exception. So this is, let's say, one of those exceptions in our rule that we have built for DP. Sounds good? So that's almost all the problems. Again, you can type in the answer. I'm not going to read it, to be very honest, but feel free to like write it if you think that you have modeled it correctly. Okay. And anyways, when we are modeling, we have these things over here. Okay. Chalo, that's mostly all there is to this particular MCQ. I think if you guys have not yet liked the stream, like kar do so that more people get some reach. This stream reaches to more people. Let's move on to the next part of the stream where we talk about the problems, right? Okay. Just a second. Okay, let's go. Subtype transition can be converted to a state which doesn't change typology but increases space complexity. But decreases space complexity, right? Why would you increase space complexity if you can? Chalo, let's move on to the doubts in the videos next, right? So we'll do that next. Okay, let me like open up my channel first. Okay, not this word. This the YouTube stream. Yeah, this word. Let's go out. Hello, hello. Yeah, so we increase the space complexity, right? DP increases space complexity but saves time at times. Okay. This is not the full video. In fact, this one is. I will remove this one after this stream. So we are in day 3. So we have 1, 2, 3, 4 videos. Okay. Okay. In fact, let me just remove this video by now. Maybe that would be helpful.
Hey, hi everyone.
Okay.
Welcome to this.
I don't wanna watch myself again. Okay.
Hey, hey, hi. Hey, hi.
So you guys would be watching me saying, "Hey, hi everyone, and welcome to this video" by multiple number of times as of now, right? But fine. If somebody sees it for the first time, it makes sense for them. Vivek, please do take sessions of every other concept. Slowly we will do. Slowly we will do. But for now, let's complete the DP first. Okay. In my opinion, less makes more sense with form 1 by keeping the previous index in the state and decide to choose from the current decision, but ultimately both forms give. Yeah. So we'll see why form 2 comes into action, because some problems cannot be solved with form 1. You cannot keep track of things with form 1, but form 2 is only way in which you can do so. Okay. Avoid using DP array for answers. Yes, that's a very interesting learning. I think we have discussed about this in the previous stream. Do check if DPR is visited earlier or not. Yeah, if you want to do this, this is a good point. Thanks, man, for like kind of summarizing 2 key concepts. These are very key concepts, right? I think I've mentioned them in the videos, but this is also important. Yeah, don't worry. I will explain all the CSCS and AdCoder problems for you guys. Okay, I'm gonna do that for you guys so that you guys can relate that how did we learn this. But coin combination 2 is mostly, if I remember correctly, that's infinite coins, right? I'm not sure. Maybe we'll take up that later. But if you have infinite coins, the way we model it, let me just quickly talk about that too. If you have like certain, so if you're at a level, right, at certain item, you can choose to take or not take, right? So if you have a single supply of this, if you take, you move to level +1, okay, and if you don't take, then you still move to level +1, okay. But if you have infinite supply, even if you take, you can keep yourself at the same level itself, but the weight will decrease or increase according to what you have kept. And if you don't take, then you move to the next level. So this is how you convert any problem where you have a single supply of every item to infinite supply of every item, if you have to do that, okay. So keep yourself at the same level, because in the next iteration also you can have the same item taken again. And if you decide not to take it anymore, you will always have this transition as an option. So that's how we kind of model such problems. Okay. So this is how we do this. Okay. सब करेंगे nice conversation. I'm gonna solve you. I'm gonna give you guys everything for that. But before moving to CSES, we need to know one more thing, which is iterative conversion of the coding. After that, we can do the CSES, add code, or everything. I mean, add code can be done without that too, but we will learn that and then we will do it. Okay. Let's go back. Let's go back to the questions. We have talked about this. Yeah, that's a nice idea actually. I understand what you are saying. You can read this one for another idea. So there is this interesting question, guys. Is everybody listening to me very carefully? I'm gonna quickly like kind of tell you guys one very interesting idea that you will find really like nice. Okay, everybody listening to
You
me
guys
very
want
carefully.
very interesting.
Chalo. The way we work is dp of, let's say, some x comma y we are keeping, okay? Now, let's say x can take the value in the range 0 till n, okay? And y can take the value in the range minus a to plus b, okay? Or let's say it can take minus 3 to plus 3. It can take a value like this. X can take any value in the range 0 to n, y can take any value in the range minus 3 to plus 3. So in the recurrence, if you write, it's fine. But when you go ahead and try to memorize this, so this is actually going to be a recurrence in the function, in the code, and you're gonna write something over here, right? If dp of x comma y, okay, is not equal to minus 1, then there is a something we do, right? This is the cache check. In that case, we are gonna return the dp value, saved value. So what we do in these cases, right, is we cannot really access minus 3 over here. So what we do is, for every possible y that is there, when we access the array, we gonna add an offset, okay? So plus offset, we are always gonna create a variable called, let's say, offset. So we're gonna return the saved value. So what we are actually saying is that the state x comma y will be saved at x comma y plus offset, okay? And in this case, we can set the offset to the value 3, because in that case, every possible value of y will now become positive, right? So this is a direct way in which you can map negative values to positive values in the array, because in the recursion, it's fine if it's negative, but while saving, just make sure that it's positive. That's it, okay? So that's how we do this. We create two arrays. What's positive? No, that's not true. This is how we do this, okay? Clear, everyone? How are we doing this? So if I just write the full code, the way it will, so this is a new concept. I just want to quickly show you guys this. I mean, you might face this someday, because let's say some items are negative also, so you should be able to code such problems as well. So I'm just taking this one problem that I coded in the day 4 problems, but I'm going to show you the idea. The way we will do this is, let's say this batch can take in the range minus 3 to 3, okay? This is the range for batch. So what I'm going to do is, so minus 3 to 3, in that case, it will, forget about these codes over here. How many values are there? It's 7 values. So I will keep 7 values over here, okay? Total range. Add. What we'll do is, we will keep it in minus 3 to 3 itself. The way it will get handled, it's similar. But only when you are accessing the dp array, we will add offset. Okay, and we will define, or you can also do constant. That should be fine. Yeah, so it will be the negative of the lowest value that is possible, most negative value. Using a map is not the best idea for this cases. This is there. Too much clipboard clicks out. Sorry for that. Maybe I will decrease that one a bit. I don't know how to do that. I mean, actually speaker is closer to the microphone than me, so that's the biggest problem. No, you should not. So that's the main concept. When you have negative values, this is how you tackle that. Okay, let's go back to the questions that we have on the comments. So this is now solved in that case. This is already, I think, resolved. Yeah. So in those cases, so when you are using, so that's also a very, very interesting idea, right? If you have to use a minus infinity in a problem, please don't use int min add int max. these are very problematic variables to certain sets, because what happens is that if you do a +1 to this or if you do a -1 to this, it will wrap around. So these are like dangerous variable to be used. In by chance, if you return it somewhere and then you use a +1 on that, it will give you wrong answer. So use something like 1e9 or even 2e9 if required. As per the problem, 1e9 generally suffices for most of the problems, or 1e18 if you have like log saved. But these are the things that you should keep in mind, that don't use like int max int mean in all the cases, or you have to be very careful that you don't add anything to that. Okay, that's something you can keep in mind. Okay, next is, yeah, it's actually interchangeable. For form 1 and form 2 are both interchangeable. So we have already answered this one, but never use DPRA directly. Always use the recurrence format. If it's not saved, it will find it out. If it is saved, then it will return the answer, right? That's what we do in such cases. Clear, everyone? So that's all the comments as of now this particular video. Let's move on to the next video. We'll resolve the comments. In comments, you learned a lot of different things. Like you might feel that, hey Vivek, I mean, it's not that good, maybe. Okay, I was expecting that it was going to become a question. Try to solve the longest common substring. Yeah, this is something we will code. Don't worry. Like this is not difficult. It's very similar that if you have the two strings as a common, if the correct common substring is a different. So there is this problem: longest common subsequence and longest common substring. Okay, common substring. So the idea for this is that you have to find the longest common substring for two different strings. And the way we do that is we keep the same idea, that this is the level I and this is the level j, and we want to find the dp of I comma j is gonna tell you. Note that it's substring. So LCS starting at I and j. So it's a bit different from the two, that the meaning is a bit different for longest common substring. But again, it should be possible that what is the longest common substring that starts over here and starts over here. Okay, and we will take the maximum across all different values of I and j. Okay, so if it is starting over here and if it's starting over here, the first character has to match or else the answer is 0. So if let's call this a, let's call this b. If a of I is equal to b of j, okay, then we have a possibility that we can extend it further. So what we'll do is, in that case, it is going to be dp of I plus 1 comma j plus 1, that what is the longest from the longest matching between these two things plus one more character. So plus one more character. In this case, this is the possibility. Or else if it's not same, then you have the answer as 0. Okay, so these are the two recurrence, two particular transitions that will be there, and the answer is going to be max of dp of any possible place x and y that we can possibly match. So that's how do it. Solve this question iteratively, could not write it recursively. Yeah, this is how you can write it recursively. I didn't get it. This should be possible. Okay, we'll see if we could not write, like we will write the codes at the end. If it is not possible, then we'll see it up. Okay, so this is how you write longest common substring. The common substring between two this. So the way it works is that if you have a b c over here and a b d over here, it will find out the longest between these two, which is just b, and then it will add one more over here, so it will get 2 over here as the answer. Okay, for this I and j, what is the longest starting at these places and matching. Okay, to certain sets, it's actually the combination of form 2 and form 3. Okay, that it is multi-sequence, but you are dealing with starting or ending. What is the best starting and ending at this particular place. Okay, so that's what we are kind of dealing with over here. For both of them, it's starting at this place. Okay, let's go back. Let's try to take more questions. Yeah. So people are finding it difficult because the meaning was a bit different. Longest common substring starting at ing. Okay. Both has to start at ing. It is not like subsequence that it can disappear. The characters can disappear over there. Okay. That's the thing. Okay. How many of you think you will be able to code it up? Quick plus one if you think you can code it up in a recursive way. In a recursive way, I mean to say. Okay, I'm gonna code it at the very end. If you have seen my LCS video, it's going to be very similar to that. Only change is that we will have a small, like, this is a transition itself. The check over here at this. We can also take LCS ending at IHA. Right. That's also possible. Just like I said, right? It's starting or ending. Both are feasible. Plus minus. I'm gonna take it. I'm gonna take this one if you guys say at the end. Okay. Don't worry. This is simpler. Like once you get the meaning, it's simpler, but the meaning is difficult. I understand that particular thing for sure. Okay. Just a sec. Like this one is disturbing. Yeah. So let's see now. Let's continue. Sorry for this one. Diplomatic action. Plus minus. I expect that to be a plus one, but chalo theek hai. But how did the screen go to minus because one के से तो बहुत दूर होता है keyboard पे. So I feel that diplomatic answer. Let's go to this one. Can prefix sum be implemented in recursive solution? I just know how to do it. Yeah, I mean, just keep the, so if you keep the meanings correct, you can do it. Okay, you can do it. Everything can be done in a recursive way. Almost everything, except some optimizations. Chalo, that's nice. Discuss more patterns we can solve using these three forms. Yes, we will keep doing more and more problems. So I will give more interesting problems tomorrow or day after tomorrow, either of them, and we will have like solving sessions for most of the problems of CSCS and AtCoder as well, so that everything is covered for you guys. Okay. Common lead code problems. Lead code problems also you want to solve or what? So I think there are a lot of videos of lead code too that I have uploaded earlier. And a good amount of them are on DP. You can check them out now too. Okay. In case, so once you have unlocked the three forms, you are good to go and solve any problem. But we will keep doing more and more interesting problems so that you can learn things. Okay. In case of end strings, how will you do it? As it would be wise to have end states. So you can keep a vector. Okay. That's a good question. Maybe I will take this one in a separate video. Okay, I will make a separate video on this problem. That let's say you have to find the longest common subsequence of n strings. How will you do that? Okay. Well, I will take this one in a separate video. Let's go to the next one. In which lecture you have explained calculation of type complexity? So this is forms. I think people have already answered it up. So on day 3 we already have more and more stuff. So I think all of those things are done. Thanks folks for commenting on the videos and helping them reach a bit. I think you guys know, right, how things work on YouTube, that if you comment a bit, things get shared to more and more folks on YouTube, and that helps me to make this content reach to more people. Let's go to the next form. Let's see. Form 4 is we have gone quite to a lot. Okay, so someone has kind of learned now. So there is Knuth optimization that brings down time velocity from O of n cube to O of n square, which is at the final line, right? For the first timers, it's difficult, but you should learn backtracking. And then you can go to this one. That's perfectly fine. So x0 and so the way I did was that I added the 0 as a new point and implemented it. There is multiple ways to implement this particular problem. You can break it down into piece sizes and then use a separate array too. So it's up to you. I will take the problems after this. Whichever problems you guys tell me, I'm gonna take the ideas of those and then I'm gonna discuss them. Is it somehow partition DP? Like I don't know what partition DP is, but yeah, MCM is a class of LRDP problems. Okay. How can we optimize this LRDP? So somebody has mentioned it's called Kruth optimization. You can search about it. Maybe I will talk about that in a future video. It's an advanced optimization, but it is possible. Just keep in mind. Okay. Whenever you have this kind of a setup of rod cutting problem, it can be optimized from n cube to n square using Kruth optimization. Thanks. Okay, so people know about Kruth optimization. So did you guys Google or did you guys already know what Kruth optimization was? Do you guys know what Kruth optimization is? Quick plus one, minus one. I mean, that's a pretty rare topic though. Do you guys know it? Google. Okay. That's what I was expecting because Kruth optimization, there are very hard optimizations that are available. Kruth is one of them, and we will not take it up over here. Okay, people have already explained. Thanks folks for helping others as well. Other videos were like kind of explained. Okay. So I think these are also resolved now. Let's go to Form 5 quickly. So sorry Unibro, I think if you have not been able to follow the videos, I understand that the pace is a bit difficult to follow. That's cool. So I'm gonna take the problems next, don't worry. Merge element 2 is a very interesting idea. Merge element 2 is also very interesting idea. Probability DP is something that we can take up later. It's a bit more difficult topic. But first we want to unlock the 5 forms and get a mastery on that, and then you can try and unlock. So once you get a mastery on the first 5 forms, right, I can guarantee you that you can learn any different kind of DP, be it probability DP, be it bitmask DP, digit DP. Digit DP is like the simplest to learn if you have learned these things. It's form 1 with 2 new states, that's it. Okay. Bhaiya, to discuss the problem, remove barbells. I will take up the questions of the things next, but let's first cover up these questions, like any questions on the videos. It's not deleted, it's getting recorded now, so that's there. So, but thanks for like kind of waiting for the videos. I guess you guys do wait up and ask me. And Ashok is like constant comment on every video is like, Bhaiya, meet up. Her video you guys would find almost on all videos I have seen. We will do that. I understand that due to restrictions, I have not been able to get time for meetups and all, but I'm gonna do that for sure. Okay. Yeah, I'm gonna definitely meet this person because he has committed so many videos. I'm gonna like maybe get him to one of the restaurants nearby. बुलाता हूँ मैं अशोक को. Where to learn C++ form? C++ form. You guys, I think I made a video on this one. Check out the stream on how to start competitive programming. I have given a playlist on Code Forces. That is also really good. But you can learn it from any YouTube channel. In fact, I think many YouTube channel covers C++ in general. I was also thinking about this, how like maybe someday I will create something called as C++ only for cooperative programming. Like how much is enough? I just want to know that much and I want to solve using that. So that is also something somebody can create maybe. If you guys know some good resource for that, good and fine. I think there are some books also on C++ that is required. So you can check out some books. I have made a book video also on that particular thing. That is there. One form tomorrow. We will not do any new form. We will solve certain ideas that is going to help you solve more problems. सर्दी हो गया guys थोड़ा सा. Will there be workshop or other topics in future? Did this workshop meet your expectation? Yes, guys. I mean, you guys are waiting over here and learning these things. That's the main idea for these workshops. I mean, if 50 people I can help, that's more than enough for me. I will make more workshops, but understand that these workshops takes a lot of time, lot of toll on time. So just an example, like yesterday night I had to like record I record immediately itself. You can pre-plan and maybe record, but I am not that person. I don't get time always. So I record yesterday and then upload it today. So that's why sometimes I get a delay and things like that. But yeah, and then like edit, thoda bahut edit karo. Like, I can show you guys how I edit and all, or like iMovies and edit it, crop things up, add transitions, upload, then export it out, create thumbnails on Canva, and then upload it on YouTube and then do it. So all these things takes time, right? Good amount of time, and then plan these things, create the slides that you see. Creating the slides take equivalent time to recording the things, right? So that's the thing. Can I start CP now? Currently third year. Yes, you can. Or did you random policy CF to increase rating? No, it doesn't help at this. It helps to get implementation skills, but at start maybe you can start in more structured way. Is it safe to use Java ICP contests? Yes, people do Java ICP contests. People have like templates. Do learn them up. Even Peter is a very famous cooperative coder who is gonna do this. But your views on Abdul Bari course. So that's a really good course, right? Abdul Bari course is something that has been created in a very very detailed way, and people like that is like explained in a very like slow pace but in a very detailed way. So if somebody finds it difficult to grasp the beginner stuff, right, it's a very good course for that. I've seen some videos of that, but obviously I have not used it for myself. Back then I was like reading from books and I could get past that level very very fast. Okay. Chalo, let's go forward now. So we are done with Form 5. So I've cleared the comments of the videos. Let's go to the problems of the platform and we will discuss that. Okay, so if you have some doubts at all, like post it on that day's videos. I was seeing some people asking their doubts on other videos. It is difficult to go through all videos, so that's why like try to post it in the same day video. Okay, but I mean like tomorrow we'll have day 4. So even if you have a doubt on some concept from day 1 and day 2, add it to the day 4 videos. That way I will be able to take it much betterly, the much better way. So understand here, you are going to compete. So there has to be this innate motivation or a fear of not getting placed. If you I sometimes feel that people say that fear is bad. I sometimes see that fear is good. If you are someone who is finding it fearful that I might not get placed, and practice with that particular motivation, it sometimes helps, right? So don't, I mean, the only thing that you can kind of think about is your career is important, right? You have to make sure that you practice enough so that you get the things. So demotivation तो I mean is not an option, right? The option ही नहीं है वो तो. अब practice नहीं करोगे तो नहीं होगा. It's as simple as that. And अगर सब कोई कर लेते तो इतना easy नहीं होता ना. अगर सब कोई contest करके अगर सब कोई अगर बस basic practice करके अगर सबका, if everybody would have got into FAG or everybody would have got into big companies, right? So there would have been no craze at all for this, right? And once you start getting the hang of it, it's actually really good. Yeah, this is beauty. That makes sense. How many stars? That you don't ask me. DP greedy is the things that you need to practice quite a lot if you're at that stage. Okay, plenty of problems. Okay. So maximum subpath in grid, these all things. So I'm going to just quickly go through the problems and then I'm going to take some questions. Okay. Maximum subpath sub in grid. Let me open the problems. Let's open the first 5 problems. Okay. So this I have already solved in the video, right? This is not a very hard problem. This is just that you have to end at this. Is this problem is clear to everyone? Can I have a quick +1? Let's do a quick +1 if everybody is clear on this one. This problem. This is the one that I discussed in the video as the ending point. Like, what is the shortest path things to this one? Okay. Okay, that's great. Let's go to the next one then real quick. Number of paths. So it's just counting the same things, right? Now you have certain blocked cells. So when you calculate the answer for a blocked cell, just make it a 0, or else rest all is going to be the same thing as the last one. We just add the number of paths from the previous 2. That's all there is to this particular problem as well. If you could solve the first one, I think you should be able to solve this one as well. Or else read the tutorial a bit. Given a grid of 0 and 1, you need to find the area of largest square containing only ones. Okay, so this is a very very classical problem. Largest square of containing ones. So you can even Google this up. you're gonna get like videos for this problem. This is a very classical problem, and the way for this is the find the largest square ending at the cell x comma y. So you can expand by the 3 cells just nearby, and you can find out the answer using the min of the 3. You can try to read the tutorial, and that should give you enough idea. I want to go to the harder problems, and that's why I'm kind of skipping through these problems a bit quickly. Okay, why bin in this problem though? That's a good idea. I mean, if you think about it, if you have this square, if there is a big rectangle, so for that, if there is a sub x rectangle over here, x length if the x length rectangle is square is possible over here, okay, then for this particular square it should have been x minus 1, sorry, not till this much, x minus 1, x minus 1, and even for this one it should have been x minus 1. Okay, for this one also x minus 1, for this one also x minus 1, for this one also x minus 1, at least this much. But if one of them is even bigger, but still we cannot really make, so there is a 0 over here, let's say we still cannot make it bigger than this one, right? So the minimum one is the limiting reagent, and limiting reagent, I'm not teaching chemistry, but it's the limiting one, and that's what we decide, that's what decides over here, right? So that's why we use bin over here. Okay, let's go back. So this is square done. 3 problems. This is in the video. I don't think I should kind of explain this. Now a day 5 star, nowadays 5 star is a chocolate. Because of getting solutions, or what do you guys think? Any chemistry? No, chemistry is not my favorite subject. You can see my LinkedIn post. I made a post back sometime. Chemistry is not my favorite subject, and I feel it's difficult to do CP if you have chemistry as your favorite subject at times. Due to some examples I've seen, but don't get demotivated. Okay, I'm just saying. My favorite subject was physics though. Okay, longest common substring. If you read the editorial idea, you will get the idea. But as I explained, that you have to be like at IHJ, and you have to find out what is the longest common substring starting at IHJ. So it's like combination of form 2 and form 3 to certain sets. Okay. Okay. So we are done with the first 5. Let's talk about the next problem. Make palindrome. This one. Let's deal off with one more easy problem, which is subtraction game, I guess. This is the same problem as in the video, right? Everybody could solve this problem. This is the same problem as the video one. Right? This is the same problem as the video one. All LRDP problems were difficult to solve. That's true. That's true. N mod 3 was like a magic, right? It's an observation, but it's a magic. So earlier I was not interested in giving the LR problems today, but then I asked to add all the LRDP problems that are there over here itself, so that you find out the difficulty things. These are fairly hard problems. Merge element 2 and remove barbells are fairly hard problems. Okay, when you say 4-star on AZ platform, it's like it's a difficult problem, 2000 plus problem for sure. Okay, so these are difficult problems. We will see easier ones first. Okay, find the minimum number of characters to be inserted into the string to make it a palindrome. Okay, how many of you were able to solve this problem? So it's a very interesting idea for this particular problem. Find the minimum number of characters that you need to be inserted to make it a palindrome. So the idea goes like this, right? Yeah, it's an easy LRDP problem. Okay, that you are you have to make it palindrome, right? So if let's say these two don't match, so you either match this by adding let's say this is A, this is B. So this is not matching right now. So you will add a so this will match, and now you have to make this much a palindrome. So either you match the L by adding something over here, or you match the R by adding something over here, or if they directly match, if it is already A like this, you can directly match them and then move forward in this much, right? So that these are the two different three different transitions that is possible. Is this clear to everyone? So in LRDP generally there are three types of patterns that we see, okay, or two or three major sub patterns. One of them is the one that you had seen in the rod cutting, that you decide where to cut, and then these two sides you recursively solve with DP, and then you merge them finally, right? This is how we do it in rod cutting problem or any other problem like merge element also that we're going to come to. But there is this second class of problems where you deal with the first or last element, okay? So you deal with the first element and decide what happens to the first element. Does it get matched with the last one right now, or is it going to get matched with this one? So you decide with for the first and last element, and then you handle that accordingly, okay? So in this case, everybody can write the code, right? I hope you guys can write the code for these things. This is fairly simple if you kind of know the way to write. So at the end, you can ask me one of the questions, and I will code it up if you guys want me to code it something on live on the stream itself. But let's first discuss the logic, and then I'm gonna code it if at the end, okay? Because if somebody's already done with their problems, then maybe that would be all for their doubts. And it's already late. I don't want you to keep you guys awake. Okay, it's never my agenda to keep you guys awake and just to keep you here on the stream, right? There should be something for you to learn. Would be perfect example of two type. Yeah. What's your sleep cycle? I don't have a sleep cycle, unfortunately. That's the price you pay. Okay, so that's the big palindrome thing over here. So I used to, in my college, I used to do practice of CP at night from 12 till let's say morning 4, 5, 6, 7, and then used to go at my room. So I used to sit in my friend's room, Nitish's room. I used to go there. We both used to sit and do CP. He's my teammate in back when I was doing even for ICPC. And my roommate even now, like he stays in the beside the other room. Maybe I will introduce you guys to someday to them. Like both of my ICPC teammates are actually my flatmates as well in Bangalore right now. Okay, so that's something that you also build up with CP. Find the minimum number of characters that needs to be inserted in the string to make it palindrome. So we have discussed this now. I will take it up at the end. Yeah. Yeah. I will do that after this workshop. Destroy Jeff Schultz. That's a very, very similar idea to the last one, but not as simple as it might seem. How do you solve this one? What was the idea for this one that you used? What did you guys use over here for this one? What was your thought for this particular problem? This is not a, like, obviously, as I discussed, a very easy problem. Okay. Like it's a bit loading on my end. I don't know why. Okay. Fine. This is something of LRDP idea where we use the same format as the other things. Okay. So how do we solve this grace Javascript problem? The idea is very simple. You try to see where does this element gets deleted with. Okay. See the first or last or something like that. Always. When you cannot decide how does something gets deleted, try to see how the first element gets deleted. This is a very, very common idea in a lot of DP problems. Okay. How does the first element gets deleted? Maybe it will maybe it gets deleted directly. In that case, you go to DP of L plus 1 to R. Okay. Maybe this is a A and it gets deleted with some other A over here. Okay. In that case, let's say at X there is a A, so you might delete it this much as a palindrome and then separately use this particular part. Okay, so we're gonna delete dp of L2 this x, and then plus we will delete the rest of the things on this side, x plus 1 to r. Okay, because either this element will be merged with some other element over here, and if that is the case, then no element over here can interact with something over here, because then this will get deleted. If something over here gets deleted with something on this side, this element will also get deleted, because we are always deleting a substring of palindrome. So if this a is kind of getting deleted over with this sub x, then you can do sub L to x plus dp of x plus 1 to r, right? So when you're deleting this one, and when you're deleting something L to R, okay, one thing we can observe, that let's say you're deleting this much, it's an a and a on both sides. So it's, if a of L is equal to a of R, right? If they are both the same thing, then it's equivalent to deleting L plus 1 to R minus 1, right? Because the way you delete this, whatever cost it takes, it's going to take you equivalent to delete this one also, because while you're deleting this one by making it palindrome, whatever last delete happens, add these two a's to the both the sides, and this will also get deleted together. So the cost over here will be to just delete this much, and that's the main idea of this particular problem. If you go to the editorial also, I'm going to quickly show that up to you guys. The editorial idea says that the first case, we will reduce the three cases. Destroy the leftmost node of I to j and reduce to the subproblem I plus 1. So it's just a single delete. Okay. So we will batch the leftmost node to some other right node. We iterate through the gem node with this up till this much. And from I, so if you batch from I to k, so I and k is batching. So you just solve the I plus 1 to k minus 1, because whatever cost it takes to delete over there, that is going to be extended to the last part, except one particular case where you have the first and second character matching, because in that case, if you have a, you don't say that what is the cost to delete an empty string, that is going to be 0. So the cost to delete will not, for this much, will not be 0. So only when the two characters are absolutely nearby, you will have a cost of 1, or else you can take these two things matching and add it to the cost of deleting this, because whatever last gets deleted in over there, you can add these two a's on the two side and delete it as well. So that's the way we decide the transition for this one. Okay, these are the three different transitions that we happen over here, and the key idea that you have to keep for this particular problem, for many different problems, this is used, even for form 1, form 2, form 3 problems also. What happens, how, if you're deleting something, how does this a gets deleted, how does the first element gets deleted, or how does the last element gets deleted? If you keep track of that, most probably a lot of problems could be solved with that mental model. Okay, does this make sense to everyone? Like some idea? Obviously you will have to read the tutorial and see the code and try to write it up, but does this make some sense? I think this is a bit difficult, but how is this working to some degree? Try to see where does this get deleted. Okay, are you sick? हाँ थोड़ा सा सर्दी हो रखा है मुझे. That's what is there. But again, उसके लिए मैं लाइव स्ट्रीम कैसे निकलूंगा? Okay, so that's the way we solve this particular problem. Sounds good? Chalo, that's the idea for this one. Next we will go to the next problem. Merge element 1. And it's a beautiful problem, right? Merge element 1 and 2. How many of you found merge element 1 and 2 to be really good ideas? At least I personally, when I created these problems, I personally thought about them to be really good ideas, because they are at least the merge element 2 was something that I created out of merge element 1. So it was like, okay, let's make it more difficult, and then we just added one more state and something like that. Okay, so merge element 1 is more like a LRDP problem, where the cost is the sum of elements mod 100. Okay, that's what we are getting, sum of elements product between the two, like whatever element you have over here, if you delete it with the next one, you are gonna get a2 into a3, the product of the numbers, and the number will result into the sum mod 100. So the two key observations over here is that if a1, a2, a3, if you merge these two, you will get a1 plus a2 mod 100 plus a3 mod 100. Okay, this is the final thing if you merge it after this as well, like this. And if you delete these two first and then these two, you're gonna get a1 plus a2 plus a3 mod 100 plus mod 100. Okay, this is what you're gonna get. Okay, so if you merge these two things in any particular order, you're getting the same cost, because mod 100, if you open across, this is going to be just the sum of the three AIs mod 100. So the order does not matter in this case, right? The way the final resulting value is independent of the order. So what we can do is we can say dp of L to R is the bid cost merge. Okay, and the way we can do that is we can try to see how did the last merge happen. How did the last merge happen? So let's say all of these things reduce to a single number x, all of these things result to a single number y, and they were finally merging into a value z. So to get all of these five numbers over here to a single number, to multiply them and get it over here as a single number, we need to get a cost of dp of, let's say this is bid, dp of L to bid plus bid. Whatever the cost to get it merged into a single element x over here is going to be dp of bid, dp of L to bid. And we know that this x is fixed. It's nothing but summation of a of I in the range L to bid mod 100. This is going to be the value x. We know the value of x because it's fixed. No matter how you merge in between, it has to be this same value over here. Similarly, this will get merged into dp of bid plus 1. This is the cost to merge it into a single value, because recursively it will find out the best thing. And the final value is nothing going to be this bid plus 1 to R a of I, the sum mod 100. Okay, this is something we can do. Now to finally merge them together, we're gonna get a cost of x into y. So the final value of dp of L comma R is, I'm gonna write it over here, dp of L to bid plus dp of, you reduce all these, plus dp of bid plus 1 to R plus x into y. X and y are these values, you can calculate them separately. Okay, and once you know this value, this is one possibility for a particular bid. You iterate over all possible bids. Bid is going to be equal to L to R minus 1, maybe. You're gonna bid across all bids. So this is what is going to give you the value. Okay, over here we just know that we have to merge them. So the final merging has to happen, right? There is going to be a final step where you merge these two things. Okay, so this is where it's kind of splitting, and like you cannot merge this element with this element without merging these two elements, right? So there has to be a last partition that is going to exist. This is like proof of that, but you know, if you have already learned this, then you don't need this anymore. Okay, and for the next part, we have a change of cost, a change of conversion, that if you merge two things you get a new number. So in that case, this x is no longer fixed to this value and y is no longer fixed to this value. So we will change the dp function and convert it to dp of L R x. That if you have to merge the elements in the range L to R to a value x, what is the minimum cost of merging? That's the change in merge element 2. Okay, if you have to merge the elements L to R to a value x, what is the cost for that? Because it's no longer fixed, right? If you merge L to R, it's no longer fixed. So let's say for a value x, what is the cost? We will it can get all different possible values over here as x. Okay, yeah. So if you're merging, let's say we had, let me go to the problem that will make it simpler. So the first problem is comparatively simple. The second problem is a bit more difficult to grasp. Okay, so x time a2 plus, so now so the idea is a b c and there is x y z, I think. So if you merge these two, you will get ax plus by plus z, whatever that mod, plus again multiplied with a plus bc plus z, right? Sorry, yc plus z, or xa plus yc plus z. So this is a number that you get if you merge this and then you merge this. But if you merge this first, you're gonna get something else. Bx plus cy plus z. If you merge them with this again, it's gonna be xa plus y times this plus z, and you can see that these two expressions are not same, right, depending upon the values of x and y. So we cannot really finalize if you merge these three elements which element it will boil down into. So we will have to, there is obviously a mod and stuff, I'm not like writing it over here, but if you finally merge them down into a single value, okay, single value x, what is the final value you don't know. So we keep that in the dp itself, that if you have to get a final value of x, what is the cost for that, and then we merge accordingly so that we can get a x value at the end. So you can see their code over here as well. What? So see, so what we are doing to calculate the value for merging at x, what we are doing is that we are trying all different, so we are looping over the mid where we split, okay, for all different possible first values, for all different possible values of second value. If you want to get this particular value, what we are gonna get is we gonna get this value only when the first part happens to get this 50, sorry, this first part happens to get fs, the second part happens to get ls, and then you multiply and get the cost, and the resulting element is this. So you calculate all these different values over here, and then you return the answer for xx. So for all different mid values, for all different first values from the first part, for all different second values for the second part, we are merging them into the corresponding final value and then getting the xx corresponding value over here. That's the idea for this particular thing. Okay, you guys see this code, and that should try. One more naming that you might see is that dp as the recurrence name and memo as the cache name. That is also very common in coding recursive solutions of dp. Okay, note that while you are, so there is a good concept over here. While you are calculating this dp, you are calculating for a single l to r only once, not singly for l to lrx. When you are calculating for lr, you are calculating for all different values of x. So there is a small caveat over here in the code too. Try to see this one again if you when you go back to the code, okay? But you will understand, because we are calculating for all different values that can come from left side and right side and merge them and get the final value. So we will save for all different x. So for lr, every different x value is now saved. You return just the one that is asked. Can you see my code for save it form 5 comments and tell me what is wrong there? Okay. No, so returning to, so the one that has, so that's a very interesting caveat. Returning the one that has the smallest cost. Okay, so what you're returning is, from this part you return x at the cost c1, and from this you return y at the cost c2. Okay, and let's say the cost c1 c2 are very less. Okay, and then you're multiplying these two values. That's not always optimal, because over here you can get much bigger cost. What happens if let's say you get c2 plus 3 at some value z, but when you merge it over here it is like some very small cost. So returning both of them as an optimal is not always possible. I know what you would have done. I can guess from what you're saying. Just I have read it once, I think, but just by increasing one cost, they optimizing the best cost over here doesn't necessarily mean the cost over here will also be optimized, right? We will have to iterate over all possibilities. So that's what we are doing over here. We cannot really do it just for a single best one. Okay, so that's the thing for this particular problem. Don't do it. You have to explore all options properly. Okay, परसों एमेजन का इंटरव्यू है. एमेजन की इंटरव्यू तो बहुत चीज़ पढ़ना पड़ेगा यार. पढ़ो, मतलब अभी तो प्रैक्टिस ही करना है. उनके लास्ट एक्सपीरियंसेस, go for experiences and that will be there. Getting the optimal cost is not going to be very helpful. Optimal cost For all different values, yes, that's feasible. Okay. Okay. Let's move to the last problem, which is remove marbles. This is again, I think, one of the most difficult problem out of the set. How many of you were able to solve this problem on your own? I don't even expect. I should expect some minus ones. I'm expecting some minus ones on the chat. Likho, minus one likho. Oh, discuss section of lead code. Yeah, this is also present on lead code, I think, by the name of boxes. I think boxes in boxes or something like that. Okay. If I remember correctly, there is this also, it's also present over there. Let's take something like this. Okay. So the way we handle this is dp of L to R. Okay. What is the minimum cost to delete the subarray from L to R? Okay. With extra X latching to the first one. So let's say there are, how many extra 4s are there for the first element? How many extra 4s are there for the first element? I'm going to explain what I mean by this. Okay. So immediately, so we will call dp of, let's say 0 comma n minus 1 comma 0. There is no extra 4s, right? This is the whole subarray. Now let's say I decide, maybe one thing that I can do is I can try and delete this 4 over here itself, and then I need to solve this much. So if I delete 4, I will get 1 square, okay, plus, yeah, again the same logic. How do you delete the first element? That's the trick, okay. So 1 square plus you delete the rest, L plus 1 to R, whatever that is, okay, dp of that. Other thing is that you delete it with some other 4. So you loop and find out the next 4, and then you delete this 4 with this 4, okay. You are going to delete them together. So to get them merged, you have to delete this much. To delete this, let's say this is the element X where you are getting a, sorry, not element X, at a position P you found a 4. So to delete this 4 alongside this 4 while deleting in the process, what we will do is we will delete everything in between. So delete everything in between, L plus 1 to P minus 1 with no extra coming up, okay. Plus now this 4 will be get deleted with this 4. So I will write dp of P plus, sorry, P to R with an extra 1 4 latching onto this particular 4. What is this saying is that you have to delete L to R. Let's say some A, B, C, D is there. Okay, you have to delete from L to R. But there are a bunch of extra A's latching onto this particular thing, which we have decided that there are X extra A's that will get deleted with this A as well. So if you now delete this just single A, you have X extra A. So you will get a X plus 1 whole square cost or X plus 1 whole square reward. But if you latch this one into a new A over here, what you will do is for this much you will get X plus 1 A's attached, latching into this particular A. So how many of A's have we put the responsibility of to get deleted with the first element of this L to R is what we keep in this particular state. It's a very not trivial problem. I understand this is not easy at all, okay, but if you understand the meaning, this is a very good problem. So let's try to solve it for something like this. Let's say 4 1 1 4 2 1 2 4 4, something like this, okay. So the way it will solve is, let's, yeah, I understand this is a very difficult problem. So let's simulate this one. So we will delete this whole thing with no extra force in the front, okay, no extra force in the front. dp of 0 1 2 3 4 5 6 7 8, okay. dp of 0 to 8 with no extra force in the front, okay. But I decide, okay, I will use this 4 and delete it with this particular 4. For that I will have to delete this much. So I will call dp of 1 to 2 with no extra 0, no extra ones, whatever is the first element, that is the extras that I'm keeping over here. To delete this I will get a cost of, let's say, 2 square. I will get a 2 square over here, and I will have to delete this much with the extra 4 latching onto this 4. So I will call dp of 3 to 8 with the extra 4 latching into the first element, okay. Now this 4 I can try and decide and delete it over here itself. One option is delete here only. So in that case you will get dp of 4 to 8 with no extra 2's in the front. But since you deleted 2 4's, there was an extra 4 latching onto it, you get 2 square. Or else you can decide over here, if you were deleting directly over here, then you could have got 1 square also. But anyways, over here you can also decide that I will latch this 4 into this 4. So you will have to delete this much. So you can get dp of 4 to 6 I have to delete with no extra 2's latching onto it right now. Plus this 4 latched into this and this 4 latched into this. So you have to now delete dp of 7 to 8 with 2 extra 4's latching onto the first element. Okay. This is something you will get as a cost, like it will delete this one square plus 2 square, then this 2 will get deleted. And this is something, now you see that this will latch into this one and you will get plus, this will convert into dp of 8 to 8 with 3 more 4's latching into it. And this is nothing but saying that you have a 4 and there are 3 more 4's latching into it. So to delete all of them together, you have to get a cost of, how much, what will be the cost? Very simply, 4 square. There are 4 different 4's, right? So 4 squares. So keeping track of how many such elements are latching into it is something that is there. I don't think like I can actually make a full video on this one. Like it might take me 30 minutes to explain just this one video. I know that I'm going very, very fast, but this is the main idea. Try to build on top of this and that will make more sense. Okay. This is a fairly hard problem. You can skip this also for now if you want. Okay. So this is the main problem that we are keeping over here. This is some problem that I would recommend you to skip for now if you're doing DP for the first time. This is a very hard problem. ये समझ गए तो बहुत ज़्यादा अच्छा problem है. That is true. This is also, I think, in the comments you can also find that this is one of the problems close to a lead code problem as well, and I think you can read the discuss as well if you want. Yeah, but using the first element is the key idea. That is something like how to design the transitions. Use the first element. That's a very, very key idea for a many problems in LRDP. Okay, either you split at somewhere in between or use the first element and latch it into something else. These are the two various cases by which transitions get designed in LRDP problems, and that comes with practice only. Okay, so that's almost all the problems for the day 3 that we had. And I think we have gone very, very overboard the 1 hour time limit. I wanted to keep you guys here for 1 minute, but 1 hour, but we are more than that, 1 hour 30 minutes almost. So we will not do more today. Again, we'll meet tomorrow with the day 4 problems and try to discuss those. Those are also really good problems. But yeah, keep solving the problems and keep like learning more and more. If you have not seen the videos, definitely go through them. What I've decided is that since I'm a bit sick, I will maybe I will not upload the videos tomorrow itself, but get upload the day 5 videos day after tomorrow. So tomorrow you have full day to complete every problem that is there till day 4, and we will get things done from day 5 or the next day. And tomorrow I will take a day 4 discussion live session like this one. Okay, sounds good to everyone? No, it's not only valid with LRDP, it is also valid with form 1, it's also valid with form 2. Okay. Well, day 5, no, the day 5 content videos is going to come day after tomorrow. Tomorrow would be just live session on day 4 problems that you have got right now, or the questions. Okay. Remove boxes. Okay. It's called remove boxes or lead code. Okay, that will be all that guys for tonight. I think that is there. अब मैं जाता हूँ, डिनर करना है मेरे को जल्दी से, और फिर थोड़ा रेस्ट लेता हूँ, कल थोड़ा ठीक होता हूँ, फिर तुम लोगों को फिर वापस और पढ़ाऊंगा. ठीक है, चलो, that will be all for my side today. Thanks for joining it. I hope you guys learned at least something. I understand that I am kind of jumping through a lot of different stuff, and maybe for the first time you might feel very, very difficult, but थोड़ा बैठो उसकी चीजों के साथ, you will learn a lot. Okay. डिनर करोगे यार, फॉर यू गाइज इट्स इजी राइट, तुम लोग तो सुनते सुनते भी डिनर कर सकते हो. लाइक यू कैन वॉच these streams with the popcorn in hand as well, or with the dinner as well. At least I used to do that. Like at least place like khate khate I used to watch videos. That's perfectly fine. Okay, chalo, that will be all. Thanks for joining it. Good night everyone. Bye bye. See you all in the next video. Okay, and enjoy your work at Google. Yes, to a certain degree, yes, but I'd love teaching you guys more. Chalo, bye.